Thank y'all for coming. Hopefully this will be fun. We're going to go over NATS as a tool for connecting things over a network. See what that means, what kind of things we want to connect, and fun ways to use this service. It covers a lot of different things. In fact, I thought we could start by going over a bunch of scenarios that might be useful places for NATS. So that outline this as a few different kinds of problems that you might want to cover. So the first, and probably in my opinion the best use case for NATS, is if you are building a microservice architecture and you need lots of different services or apps to talk to each other over the network. NATS provides a good toolbox for doing that. And we can discuss how NATS could probably simplify a lot of deployment architectures for that kind of scenario. And we'll see that as we go along. Another problem type that you might have, or a business might have, would be kind of Internet of Things stuff. So NATS is really good about working with a variety of protocols, one of them being MQTT, I think it's called. It's the one that needs like a primary IoT sort of interface. It knows how to speak that. So if you had a bunch of fielded IoT clients or devices that are plugged in that somebody's, whatever your business is doing, it can serve that as well and be like the sort of nexus or brain for your service if you needed to be communicating things there. So that's another area where you might want to use NATS. Another thing that you might have, let's say you are in one of those systems that has a lot of moving parts in it, and I know I've seen this at some of my work environments where we deal with reliability issues because we have too many services that are talking directly to each other over synchronous communication. So a lot of HTTP calls that are point-to-point between services. And when you have that, it hurts reliability, hurts your uptime, because if any of those links in the chain fails, then you can really affect whether your service is up or down. But by using NATS, you can change that synchronous kind of connection into an asynchronous connection, so that services do not need to be directly dependent on each other. So it can really help improve reliability on some of these kind of systems. And we'll compare it to other...
You got to change the services to do that, though?
Yeah. This is not like just transparent. It's there is some design considerations that come along with that. And and it compares to other technologies that are in this space. So I'll try and highlight a couple that are kind of competitors to NATS. I don't know that I have a direct slide on that, but we can certainly talk through them. And then the other kind of fun one here is I think it can just be a fun technology to play with. So if you're more of a tinkerer or you're looking for fun projects to do, I think this is a good way to really blow up some boredom and have fun with NATS. Okay, so NATS is here to help all of these different kind of problem scenarios with what it does. So let's talk briefly about what NATS is. I pulled this quote from the NATS.io website. This is what they pitch themselves as, is software applications and services need to exchange data. NATS is an infrastructure that allows such data exchange segmented in the form of messages. We call this a message-oriented middleware. That felt like pretty enterprisey language to me personally. So I was thinking of it more as a message broker, which I guess is also enterprisey, but the idea of message exchange and being a point to handle these messages. But I carefully added ++ at the end of that because I think if you have experiences with certain message brokers, I think it goes beyond that. Like if you've classically, in my mind, RabbitMQ is something that comes to mind. And I think that it does more than what RabbitMQ does. So we'll see how it extends beyond this. All right, so NATS supports a wide variety of different modes for developing. And the two things that we're going to do demonstrations on are at the top there around message styles and stateful handling. And then I'll talk to the bottom middle section later about how NATS enables these things to really make development even easier. But we'll cover the primary patterns to give you a real flavor for what NATS does, and then we'll cover the other bits there. So everything is in this concept of messages. You're passing around data rather than having systems directly communicating with each other. Sorry, just checking if we had one more attendee. So we have this style where you communicate via messages rather than direct connections, and it enables certain patterns of communicating by using message styles. And then also through using an extension that's available then right out of the box with a certain one extra flag, you can get extra stateful data handling with your message broker, which kind of turns it up to 11 with what NATS is able to do. There are these features at the bottom here about load balancing and service discovery that are very good tools for helping in a microservice architecture, and I'll talk to a little bit later about what those look like. So what I'm going to do is go through each pattern, describe how that works. We'll do a demo and then kind of flip-flop back and forth so we get some interactive breaks between this. And hopefully you get a clear idea of what NATS is doing. NATS itself, to speak to that, can be deployed as simply as a binary. It is written in Go, the Go programming language, and can come as a single binary, but it can also get all the way up to huge, massive, multi-region scaling things that are talking to each other over raft consensus algorithms. Like, it gets complex, or it can get complex if you have complex needs for high availability, large failover, disaster recovery scenarios. So we're going to use it at the most simple end here, where we're going to run NATS on a Raspberry Pi, because it could even get down to that level. But you can also just put it in your place of like, hey, if I have a big system, is NATS going to scale up to that? And the answer is most likely yes. That if I brought up what was the industry like, the logos page, like what are your brands that are there? There are some really big, gigantic companies on there like Alibaba and huge companies that are making use of NATS, at least according to their marketing material, which I have no reason to doubt.
This was the Cloud Foundry messaging.
Oh, is that right?
Solution, yeah, it came out of Cloud Foundry.
Oh, cool. I was unaware of that. So yeah, we've got
They might make those claims because those companies use Cloud Foundry or something.
Okay, yeah, might be indirect. It's interesting to know what that would be directly. I wonder who their customer set is. So our first idea here is that we've got a publish and subscribe model. So the idea is that in this diagram, which I pulled from the NATS documentation, these are not mine, just full credit where credit is due. We have the services that are in the pill-shaped boxes here, and one service is acting as a publisher, and it has a message that it wants to send. What is listed there as time.us is considered a subject. So the messages are sent to subjects. And so a subscriber, in this case, can listen to that subject and receive any messages that it wants from that subject. Yes?
Would the RabbitMQ be like a channel? Is that the lingo that?
And so compare it to RabbitMQ, I think they actually have the name of a queue.
A queue? Okay.
I think it would be most analogous to that. The other comparable piece of technology here is Kafka, which would be like a Kafka topic.
Right.
So this is the message going across here is just the NATS protocol. This is their own protocol.
That's right. It's a NATS specific protocol in this process. Where I get a little wishy-washy on my answer to you, David, is that the subjects have more flexibility than queues or topics. Like the way I view Kafka topics is they're kind of need to be created in advance. They're kind of heavy. What we can see with these subjects is they're actually very lightweight. They can allow for a pretty dynamic nature. You can actually do like wildcards and a bunch of interesting stuff on them, which leads to some pretty cool patterns, which we can explore a little bit here. So we've got a publisher. So again, the core thing to get is like you publish to subjects, you have a message. Your message is whatever data you want to put in there. It's just a set of bytes. I think there are size limitations on there, but so you could put in JSON data, you could put in protobuf messages, you could put in raw strings, which is actually what we're going to do this evening. Whatever you want. It's kind of up to you. And then the protocol is mostly about delivering those bytes to your subscribers in this case. So anyway, that's the publish subscribe pattern. Anybody have questions about that before we jump into a demo? Cool. All right, so first thing I'm gonna do is show you off all of my example code that we're gonna look at tonight comes from Go. I feel like Go has a pretty good client implementation here. I don't know if that's because they also wrote the NATS server in Go and you're just most familiar with it, but it's kind of C-like. If you've not experienced Go before, hopefully there's nothing too crazy in here, but we'll see some examples. And I think before I actually run it, I need to get, how am I gonna do this? I realize now that all of my Go examples were meant to run with a local NAT server, not the remote one. So I think what I'm gonna do, when we do the interactive piece and use the Raspberry Pi, we'll connect to that in a moment, and I'll show you how there. But when I'm doing these first examples, I'll just have a local NATS server running that we can take advantage of.
Set a NATS URL. That code say it just gets the environment variable for NATS URL.
Yeah, you're right. That's a good point. Yep. So let's do that. So I'm going to come over here. I'm now on the Raspberry Pi, and I've got the binary already available here. We're just going to run it as NATS server to start.
Is it possible to, when you're like on the very bottom line, we can't see it?
Oh, bummer. I can here. I'm just going to resize my terminal a little bit.
But no, can the screen come down anymore? Or is the screen fully extended?
Okay. That last line is server is ready, so it is kind of getting cut off there a little bit. Let me just do. It's okay. I can lose a couple lines and. How does that work?
That's better.
Okay, cool. So.
Is the line that you're typing on is the one that we can't see?
Yeah. The most critical line of all is invisible. Thank you for pointing that out before I got too far into this. So we started up the NAT server that's on this Raspberry Pi. It's communicating over, it's doing its broadcast address on 0000 on port 4222, and that's the default NATS port. The local network that we've got this configured on is, what did I SSH to? So this is when we're going to do our connections here, we're going to do to the 192.168.16 subnet, and the IP address for this Raspberry Pi is 208. So as we run commands on this a little later, we can put in that. So I'm going to go over to my area where I've got my demos, and I'm going to export the NATS URL to that value, so it should hopefully connect to the right thing as we run these different demos. And I'm going to go to the pub/sub demo. But before I run it, let's take a look at the code briefly and see what it's doing, and see if we can do some prediction, or I can explain some aspects of this. So we're going to connect to NATS with the URL here, and there's a defer here to actually make sure that messages get drained later, so that there aren't any like leftover messages that are behind. NATS does some buffering stuff along the way, and this is just to make sure that you're not losing data as you're leaving the Go interpreter. And the first thing we're trying here is we're trying to do a publish to a topic, and then we set up a subscriber after that. And the reason that's set up this way is to show that in its default mode, NATS is like you have to be connected at the time. So when that message is published, there's no active subscribers connected. So presumably because of that, once we call the subscription and ask it for a message, then we should see that this message that comes back there's not going to be anything there. So this one, essentially this greet Joe message, disappeared into the ether because nobody was listening for it. And then after that, we've got some more publication of a couple of messages. Also to observe here, these are all subjects that are varying by this Joe, Pam, Bob attribute here. So it's kind of showing like you can make subjects super lightweight of I want to have a very specific thing. You can think about putting identifiers in these subjects and that sort of thing to help do some filtering, and we can maybe we'll see a little bit of how that filtering is performed when you set up subscribers. little bit later, but there's some cool filtering rules that allow you to take advantage of that kind of structure that's put there. And then we're essentially just printing out these messages as they go along. So nothing too crazy there. Yep.
You might have just said this. Can you explain again what the 10 times time millisecond is doing? Is that going to like tell it how long to pause for? Or
Yeah. So that's I want to say that's a timeout.
So it will
Yeah, it's a timeout.
synchronously wait for 10.
Correct. We are using a sync subscriber here, and in order to be in that mode, like there's an asynchronous subscriber as well. I'm pretty sure that has a more complex setup of like how it's going to listen for things. I don't remember if it's on a channel. I didn't look up those details in the Go API, but we're starting with a synchronous subscriber, and because it's synchronous, we have to give it a timeout. Otherwise, it'll just hang indefinitely. So that's why that's there. And we're saying timeout after 10 milliseconds if you didn't get it. Okay, so over here then we should be able to go run dot, which should run build our main Go file, and it didn't work, sad. I don't know if that's because it didn't connect to the right thing. That's listening.
Said you tried to dereference a null pointer.
Yeah, so this is this code is not super robust in how it's dealing with connections and that sort of stuff. There are ways to make this like more battle hardened. It was mostly for a demo. So it could be that we tried to pull from some location at the next message and it wasn't actually working in reality. So let me try this. Let me just I'm gonna switch to I'm gonna switch this back to localhost. 127.0.0.1. Hopefully that works. And then over here, I'm going to run a second NAT server. Again, apologies. I designed these things with localhost in mind, so I didn't actually test it. Okay. So I don't know what the deal is with why the server wasn't working on the remote. Not sure. Hopefully it doesn't happen to us when we try and test it out as a group thing. But here we got our example of, remember when I showed the code, we have that first published message before the subscriber was connected. And then we created the subscriber, we connected it, and then we asked for the message. And it gave back a response saying like, hey, I don't know, there was no message there. And then subsequently, we published more messages, but the subscriber was connected.
Did you publish to greet.star and then it just sends them to all of them? Or did you?
Yeah,
You published
yes.
to.
So greet.star is a wildcard, is an example of the wildcard syntax. There's like more specific, like if you want to.
I was confused. I thought you subscribed to greet.star, and then if you publish, I thought it was the other way around. You subscribe to like greet.joe or Pam or whatever, but if you publish to greet.star, it goes to all.
Correct. Yeah.
Well, can you publish to greet.star? I guess you can.
I think so. Star is like a reserve character. Like there are two reserve characters in the wildcard pattern matching stuff. One is a greater than symbol, so point, and it's a certain kind of like restricted matching. And then the star is like slurp up everything. So if you,
I guess there's two directions here. So what you're doing here is you're subscribing to anything on Greet.
correct.
But you're publishing the specific things on Greet.
Correct. Yeah.
And
Sorry,
seeing,
point that out.
will the reverse work? Could I subscribe to a specific thing on Greet, and another guy subscribes to something else specific on Greet, another guy subscribes to something else, and then when you publish to greet.star, it goes to all three.
I don't know. That's a good question. I'm not sure if it's like
If
a
the
broad.
wildcard works one direction, I was wondering if it works.
Yeah, I would guess this with my guess is based on specificity rules is like it would probably say no. I really only care about greet.bob. I don't want anybody's junk. Like I want to know about Bob. That's it. But I don't know. That'd be an interesting thing to try. Yeah. So okay, let's attempt the interactive thing and let's see if it works. So there's the NATS client that I asked you all to install has some built-in commands. Yes,
Sorry to pause you again.
it's okay. This is fun.
But when you subscribe to those and you pull those off the queue, did that pull off the queue for everybody? So, for example, if there were two connected, would they both be able to receive those messages, or for example, if that one like received those 3 messages and then later another one connected, would it then be able to receive those 3 like 5 minutes later, or would it?
Yeah.
And I guess that might be what the defer cleanup was doing at the top of your
The drain.
The drain.
So I think the answer to your question is you can have multiple subscribers, and if they're listening to greet.star, they will both receive the same, like the greet.bob message will go to both subscribers. It's not like one of them claims over the other. There may be ways to control that, like if you're trying to do some load balancing situations. I can't remember. There's a bunch of options with when you have multiple things participating, how you can configure them to behave. But yeah, it's like sort of like that's where what we had in the picture, like this message time.us, we've got 2 subscribers that are listening to that subject, so they will both get like if this was labeled, this would be message 1, that would be message 1, message 1. They both get the same message.
Okay.
So you can have different subscribers doing different stuff. Okay, so in theory, what I should be able to do is I should be able to create a subscriber, and then you all could add, you could publish. So NATS comes with a built-in subscriber that rather than writing code, if you're just trying to play with it, listen to a topic or listen for a subject and get whatever messages are coming in. And then in the same token, it also has a client to do publication of messages. So I thought for our interactive little demo, we could do, I could create the subscriber up here, and then y'all could publish messages, keep it family friendly. I got a recording going, but see if they're actually getting there. So let me try this out. And so the subject we're going to use is message.test. And I'll get the subscriber going here. And again, the IP was, I think, 192.168.16.208, I think. Is that right?
It will fail if you attempt, I assume, right?
Yeah, I could have just tried it. Okay, so now I'm subscribing on this. So if y'all want to try doing a NATS pub, put in this server flag and the subject, and then what's important, I got my little cheat sheet here, is this. After you put the subject, you put in the message, and if you want to use spaces, put it in quotes, and it'll send that over as like a bytes payload. And we should, in theory, be able to see a message if somebody's typing it up. And if it doesn't go, I could have my own publisher as well, trying to connect.
Yay.
Hey.
Oh, I was trying to do let me see. There's a way to embed things in here.
Oh, is there?
Yeah. There's templates and you can embed things in the message.
Nice. And then, so, okay, you were asking, David, you're asking about like what happens if we have, so we've now received a couple messages, right? Let's do this. Let's do.
It uses like Django syntax.
Well, so wait, hang on now. But you didn't. Oh wait, no. Sorry,
So
you did
Rich.
not put the wildcard in.
Correct. I just did message.test as the subject I'm listening on. And both you and Rich is now sent. Oh, there we go. You got it working. Cool, Rich.
Now if I keep sending you ones, it's going to it's not counting up automatically. It's just going back to 1.
Okay. And then if I go over here and come back to another terminal, now this one's tiny, but I'm going to put, here, let me make that bigger. Although I think I just screwed up I got to resize the window again. It's okay. So I now have a second subscriber that is listening on that subject. And if somebody wants to send another message.
So I've also been subscribing to the, there you go.
Oh, you've been getting them too?
Subscribing to these, and I've been getting them. And something that I've been subscribing to msg.star,
Mm-hmm.
and I was confused for a second because I was doing msg.test.hello, and that is not appearing. However, if I do msg.test-hello, it does appear. So I think somehow because
Yeah, I could be, you know what it is? One of them is like, and I said there were two characters, that the star and the greater than. I might have it backwards. It might have been this. So the dot is a significant separator.
Mm-hmm.
In your subjects, you can set up thing, dot, thing, dot, thing, dot, thing. Okay? And I want to say that maybe the star only works on between the dots. So if you tried, here, you could test that theory out by trying, like, change your subscriber from the star to using the greater than symbol. And I think that one might be like slurp up everything after that dot so that your multi-dot thing could work.
That is exactly what happened.
Okay, cool. So yeah, there's some really powerful patterns that just out of having that amount of messaging, like you can think, and the documentation gives some examples of like orders. And so you could say orders dot country dot like order number dot status. And so just by having that sort of segment, you sort of create a almost like a mini schema out of your subjects. You probably don't want to go crazy with this, but you could see one subscriber paying attention to just statuses changes on these orders, like pending, like if it's shipping of orders, pending, shipping, shipped, fulfilled, whatever the things are, just paying attention to that, while another is paying attention to some reporting on countries, like this one went to US, this one went to Canada. And by having just playing around with that subject thing, you could parse that out very easily and make subscribers that do different things based on the subject type. So that's pretty powerful.
So now I've stopped subscribing as well. If you also stop subscribing, and then we send like a few messages, when you resubscribe, would then you pick those up?
No. And that's where we'll get into this a little bit later with the streaming aspect. That this is so the benefit of this approach is speed. Like this is a like NATS can like fire and forget almost. There's a little bit of I think there might be a little bit of acknowledgement. I don't quite remember the whole protocol specifics, but it doesn't keep any memory of this stuff. There's not really like a true buffer out of that. But what we'll see in a little bit is how we get that buffer. And Rich is having a good time with all of the template fields.
Man.
It's cool. I like it. All right, cool. Let's move back to this presentation and move on to the next pattern. So that was our publish subscribe pattern. And now you can also think about a request response pattern. So in service architectures, this is commonly implemented with either like RPC, like gRPC or Connect RPC, one of those things. Or you could do this with REST APIs and have this done over HTTP connections, that sort of stuff. But NATS enables this same sort of pattern to be possible. It does it in a slightly different way under the covers, but most of this is pretty transparent to you. If you're, as we'll see in the sample code, you create a request, you get a response, sort of thing. But what's really happening from NATS perspective is that the request message has in it a reply to address of like, hey, I'm sending a request. I would like a specific reply, and I'm going to give you, Mr. Subscriber to this thing, whoever is able to answer this, whoever is able to respond to this, I'm going to give you the subject that I want you to reply on. So it becomes a pair that works together to enable.
So it's like a one-time. I'm forgetting the word. Message topic, not topic. That's Kafka. What's it called?
Subject. It is like a one-time subject thing. And what's cool about this is it allows for I think they call it, what do they say in the docs? It's something like network transparency. So think about a typical arrangement where you're doing a point-to-point RPC or REST call. In order to make that response work over the HTTP layer, it has to know that it's coming back to the same, like it's responding on the same, layer 7 stuff and sending it that way. With this mode of responding to the subject, like the publisher doesn't need to know who it's talking to. It only cares about, I'm sending a message, and whoever can handle that message, doesn't matter. That's somewhere else defined. And as long as I've told them, hey, my response location, my response subject is over here, they can close the loop themselves and get that. So you don't have to know.
But the publisher's not blocking right then. It's going, so it has to like send it and then pull for the response, or what's it?
The publisher does have a block. I mean, I think there are different modes to this as well. So there's like a timeout aspect too. So if you're essentially, just like you would have timeouts on your REST calls or your RPC calls, you put in your timeout, and it's gonna, while that timeout's happening, it's gonna wait on listening on that subject channel. Sorry, overloading terms. On that subject, and just sit there. And once the timeout expires, then it's gonna, whoever was supposed to respond missed their window, just like in a scenario where you'd have timeouts on other API calls. So this is pretty cool in how this works, and like I said, it's pretty transparent to you as a user of this, which we can see in the code. So that's all I really wanted to talk about from the pattern perspective, and let's take a look briefly at what that code looks like. So we've got our request response stuff here. Again, we're connecting and we're going to drain, and we are this time creating the downside of these examples is that the code we're doing here is acting both as the subscribers and publishers. So hopefully that is, you can kind of differentiate in your mind of where it diverges. So we have a subscriber that is able to do a response pattern, right? And just by using the proper API call here, you didn't have to worry about how to set up that response. It's all kind of handled for you. You just provide the payload essentially. And so the subscriber is going to do some responding, and on the publisher side, we're going to do the requesting, where we're asking or sending out greet Joe, and then we're going to wait for the response data. It's going to block here. And that's that timeout. So we're waiting for 1 second. That's that third option. And we've got the response, and we can print that out. So pretty simple pattern in that regard. And then by the time we're done, we can do an unsubscribe and do another request, and we can see that, I think we'll see that the request doesn't go anywhere and kind of times out or something like that. All right, so let's try it. We've got, whoops, wrong button. I'm gonna stop that publisher, go to our other demo area, and I'm gonna do go run dot. And so we see the responder built its response message. It took off the subject and parsed out the first 6 bytes of the subject that were greet and the dot. So it pulled out the name and built a new message out of that, and sent it back. And then finally, when we unsubscribed, there is no longer a responder. Then it says, hey, there's nothing to respond to.
Interesting that it didn't even time out. It was just like there's nobody who's capable of responding this, so it immediately failed.
Yeah, that's true. I guess I didn't really think about that, but I think you're right. Like, it just kind of went right away. That was not 1 second. It was definitely less than a second. So maybe the NATS server was able to say, hey, I know nobody's listening. This is speculation on my part, so take that for what it's worth, but I think there's something there for sure. All right, cool. We've got another little demo of setting up replies and requests. So over here we can do our NATS. I'm gonna set up the thing that's doing the replying. And there's a reason I'm gonna have set up 2 of these, and you'll see why in a second. So let's get one of them going, and I need to put in the server. Server 192, 168, 16, 208, right? Okay, so you can see that we now have this replying thing that is listening for the help.please subject and is going to reply with this message of, okay, I can help. And it talks about this in group. I honestly don't remember what that's all about. I think it has to do with how it's doing responses, but I can't speak more intelligently on that. So what y'all need on your side is NATS request with the subject, and then whatever you want your subject to be. So I need help or whatever.
I just say something and send a response.
Yo, help. Cool. Did you get a response?
I did.
Excellent.
Oh my goodness. Hello. That is very weird.
Now the next thing I'm going to do is I'm going to set up another responder. And I specifically put a message on it, or a different message than the other one. And so if you keep doing your requests again, what you should see is I don't think it's round robin, I think it's random. You should see one of the 2 responders, like doing the response here. And I think the term for this is called a queue group, I believe is what they call it. But the idea is like, this enables very trivial load balancing to be added to your system. So we happen to be in a scenario where these 2 are different, but you could think, maybe I have a certain volume of API calls, this request response pattern, and I need to handle the load. And so I need more instances of my service to be available to respond to those different requests. Or I am switching from version A to version B, and like I'm trying to, have that be not like a turn it off and turn it on, but there's actually a transition period where you can have both of them on the same subject listening, and they're part of the same queue group, and NATS will figure out how to distribute that. That weighting can be controlled through some configuration, but by default, I think NATS just kind of does it at random or some kind of algorithm
So
that
the
it figures
round
out.
trip times, it's like 5 to 10 messages a second. So it's getting like 100 to 200 milliseconds.
Oh, is it?
Yeah.
Yeah, my Raspberry Pi 3 might not be up to the challenge.
So I'm only getting responses from the first one, and I just did like a.
Oh, I see why. My bad. I didn't put the server aspect on this other one too. That's my fault. I forgot that I have that other local server running. So,
Yeah, I put in
my fault.
like a for loop to try and see if I could.
You're like hammering it. It's like one thing's over there probably chatting away. All right, try it again. Whoop. Disconnected due to EOF.
Oh, I got that too.
Did we overload the Pi? I don't know. Oh yeah, we killed something. All right, let me start that up again. The NAT server's running. We're performance testing a Raspberry Pi with NATS in real time. Okay, that's running. Anybody want to try sending their requests again? Did it crash again?
Sorry, that's probably me. I'm spamming it. Alright, I'll slow down.
Yeah, using Apache Bench equivalents on this is probably not going to go so well. And it could be like I've not done like I said, I did all my demo stuff on this local machine, so it's very possible that this Raspberry Pi is just not not up to the task here of who knows how much memory is required. I don't know. I've not explored this deeply. It seems like we keep crashing it. So I guess you can take my word for it that this, I promise this does work.
No servers available for connection.
Actually, you know what? Why don't we try this? I have this local server, and I know that my MacBook should be able to handle this. So let's switch. My IP for this machine is 96 on that same subnet. So let me switch where I'm connecting to have some responders, and then we'll see if my Mac is able to handle the load here. 96 and
8 milliseconds. We could do about 100 messages on this one instead of 5.
okay. 96. All right. So now both of them should be running, and but they've got them doing the same message. Sorry, guys. I tried to do the history, and okay, there we go. Should finally have this set up for real.
There you go.
And you should be getting different responses, I hope.
Yes, I am getting.
There, I just finally got one of the other ones.
Okay, sweet. Cool. So that's the request response pattern as implemented by NATS. The important takeaway is it's got this separate response subject where the responder is going to send to, and that's I believe that comes as the NATS protocol has some basic headers, kind of like you'd have HTTP headers, and I think there's a reply to header that is sort of embedded in the overall message envelope that goes around with this. Okay. And I guess since our Raspberry Pi keeps dying, we can just use my laptop for the rest of the demo. It was good for Flash, but not good for performance. Okay. Next, we're going to talk about streaming. And this is where you can compare to, I think Pulsar has this. This is certainly where Kafka is going to be the most obvious thing here. But the idea of streaming is that you are writing to a log, and that log can hold messages over time. And the cool part about having a streaming log is this notion of, what's down here is these are basically a cursor. Any consumer on that log can look back at any point in history and just pick up from some point in the log and say, okay, I'm not all the way ahead on message 10 where the producer's now adding messages. I'm way back at message 1 and I need to catch up. So different consumers who are doing different things can move at their own speed and time and consumption rate, and try and handle data that way. This doesn't come for free. So the cost of streaming is there's more, I don't know if handshake is the right term, but there's more acknowledgement that has to go between messages here, because there's a persistence to the log and then things read from the log. And so there's some stuff around there. Again, this is configurable too. So you can set it up so a producer is blasting at the log and not waiting for acknowledgments that it got to the log. It depends on what your need for reliability and deliverability. So you've got some knobs to turn there. And then the other big and hopefully obvious aspect of this is if we're storing data somewhere and we're keeping it, there's a storage problem now of what do we do? How long do we keep messages? All configurable again. And you can have this stuff so that it drops messages of a certain age, or it drops after X number of messages. There's a ton of different ways that you can manage how long to keep your log. And the other thing that is worth considering when you're thinking about that is, hey, what if I'm trying to make my log represent the state of the world about what this kind of producer is doing? But I know I don't have infinite storage. What can I do about that? In that scenario, there are features to kind of take, imagine that we can only store 10 messages, let's say. And so the producer gets to the next one, and or 5 from now, and it needs to take those last 5 and it needs to drop them because they're too much space. So a pattern that can happen, and I can't remember if NATS can do this automatically or if this is something you have to build, is you can essentially make that like a checkpoint. Like you can condense the messages down to, oh, here was the state of the world at this point in time.
Mm.
So if you have, at that point, you don't have a consumer that has to go all the way back to message 1. Instead, it starts at new message 5A or 6, whatever. I don't know how it would affect the sequencing, but that has a summary state of the world and can kind of pick up from there. So it's a way to like compact logs over time and keep a moving, rolling set of state.
Kind of like how Django has like the migration squashing.
Yeah, kind of like Django migration squashing a little bit.
So
in this, the producer won't go back to the beginning and start overwriting?
Correct.
It won't do that?
The producer will not go back to the beginning. And yeah, so it's only appending to the log, and that has to do with some of how, I believe, how the data structures for this type of model is set up. Kafka is able to achieve its scale, and I assume this is true of NATS as well, by using a very specific data structure that is writing at the end of a file because it doesn't want to do like random access throughout a file, and that's how it's able to get its volume possible. But that means that the producer is basically staying at the front of the line the whole time, and there's some kind of process later that does the compaction and cleanup things.
So when I would have most use for something like this, you would generally want to know if one of the consumers has finished and handled one of them, so that way the other consumer could know to not duplicate the task or not duplicate the task. Like the events would be like change records to the database or like create records to the database or something like that. And so if you had 2 consumers and they both picked up the same thing, that's a problem. Is that not what the streaming would be best used for, or?
So I think the way I would view consumers as presented here is consumer A and consumer B are doing different things. They're not just instances of the same consumer that would be like then racing with each other.
Forward in the stream.
Correct. Yeah, it's like consumer A is, okay, I'm done with message 1, I'm moving on, and I don't care about consumer B. I don't even know consumer B exists.
It's like 2 people watching the same content on Netflix and they're just going at their own.
Yeah, that's probably a good way of thinking about it. So that does raise interesting questions about, well, what if I have, I'm taking these messages and doing something really performance intensive and it's slow and I want to scale that up. Then what do I do? And I don't have a great answer for that off the top of my head about, I have consumer A and A prime, which are just 2 instances of the same thing. And how could they coordinate with each other on, I'm going to take message 5, you take message 6, and maybe it doesn't matter. Maybe if it's like if each message is independent, then it would be okay. So you can make your consumers like either idempotent in how they react to things. There's probably a bunch of techniques, but if there is time-related temporal dependencies there and message ordering matters, then that's where you have to be a little bit more careful. I think one of the policies, so there's some policies that could associate with this. Here's where I think I saw a method for this. It's whenever you have to deal with strict ordering, you're probably going to take a performance hit because there's coordination there. And one of the policies was, I'm only going to be able to allow you to pull one message at a time to a particular subject. So if that was a scenario, that's where you could have A and A prime kind of duking it out of, I'm going to take one and the next one's ready. But that doesn't really address the scaling aspect, so I'm not sure how you...
And now I'm thinking about it, oftentimes the problem is that there would be duplicate producer entries, and you would want to not address all of them.
Right.
Um,
Yeah. So you get into what's the delivery. So there's like the whole, at least once, at most once. Like there's a different options on what you can expect out of the behavior of a messaging system, and what you sign up for determines how you have to write your code to adapt to. I might be missing data. Is that okay? If I'm not missing data, do I would rather have duplicate entries and then I deal with item potency so that I can reprocess the data and know that I haven't done something twice, like credited somebody's account twice with the double balance, like any that kind of stuff. So those are all different factors that you have to think about when designing with message systems. Those are reliability comes at a cost, I guess, is maybe the message out of that, is that you can make systems more reliable, but it forces you to think in a different way. Whereas if you're just doing something serially, it's easier to reason about and probably slower, and it has that trade-off there.
So actually, just kind of to make something more concrete, that your example of like charging, that's similar to what's been going through my mind as I've been thinking about like a past code base that I worked on that had a very in-depth RabbitMQ integration between like two applications, and so so if there was going to be like a charge processed, then the one system would basically throw it on the queue, and there might be multiple servers that are willing to pick up from that queue.
Mm-hmm.
And so you'd only want one of them to pick up the item. But then also, if there's something where like that event gets triggered twice, and that's more on the producer to be able to stop that from happening, to make sure that there's no situation that they would accidentally double fire an event. And so that's like the one case, and then the other case is one where the producer is less concerned about double firing an event, which is just like, hey, this record was updated. This record was updated.
Yeah.
And then the consumer, like, there's multiple tasks to say, okay, let's start a sync task. So if two different consumers say like, okay, let's start a sync task, then they're going to be conflicting as they're like trying to do the syncing process. And so that was the case where the consumers, it's kind of on the consumer to decide, hey, have I already heard this message?
Right.
Because the producer doesn't have as much, like they don't care as much if they fire like, hey, we updated this record 3 times. Whereas the consumer's going to be like doing the heavy lifting to do like performing like start up a syncing process.
Mm-hmm.
Sorry, I'm kind of just blabbing, but I'm just trying to wrap my head around like.
Yeah, this stuff it gets tricky. So I think in those kind of scenarios you're describing, where consumers are expected to interact with each other, is sort of I think what I hear you describing. That might be where I might consider other tools potentially, like other kind of either workflow tools. In fact, I mentioned earlier I did the recording and I had just the audio recording. So I presented at Python Frederick about Temporal, which is a tool for doing workflows and doing something called durable execution. So they can kind of, I can't do a whole temporal talk right now, but it's a really powerful tool for doing that kind of coordination where you have activities that need to interact with each other and need to manage state and deal with failure robustly. And so that can be a powerful tool to reach for when you have more complex workflow scenarios. You can do a lot with this streaming stuff, especially if it's independent kind of activity. So it all comes down to what problem do you have to solve with whatever you're trying to build. I should note here, so this is called as streaming. If you're on the NATS site, this is enabled by their JetStream. Is I think at the beginning of this talk I mentioned there's an extension, and so that's what we have to do to enable this. And again, there's the trade-offs are around speed. So I'm going to start up the NATS server. This one's tiny, sorry, but it's the same NATS server call with there's a dash JetStream flag. It's probably can't really see it there, except they put it in a nice bubbly text font there. So that just sets up some extra data storage and stuff on the NATS server side, because we need storage space for each of these streams. So there's a slightly different vernacular. Previously we're talking about subjects. JetStream uses this notion of streams. They can behave like subjects in many ways. So if you had a client that didn't know about JetStream, I think it could talk to the streams as subjects. But if you want to take advantage of the things that streams do, then you have to you have to have the client be talking about a stream and have it know it's talking about a stream. We'll see that in the code example. So I've got a streaming example here. And again, I pulled these examples all from the NATS documentation website. So the first two were kind of nice and brief. The latter ones that I could find, they just get a little longer, bloated. Hopefully we can still see the value here. And the reason this one's a little longer is what this script is doing is actually creating the stream during the script. In practice, in actuality, in the code that you would write, you'd probably have your infrastructure as code or some other process do the stream creation, would be my thought, unless you have to do something really dynamic. And so you would have that stream kind of set up as, again, kind of thinking more like Kafka topics here, where they're a little bit more permanent. So you have that stream set up, and then you interact with the stream as necessary. But we're doing both of those things here because you have to do this stuff in advance, otherwise NATS says, what are you talking about? Nothing like that exists. So at the beginning here, we've got our stream that we're going to interact with called events, and we're creating a stream, and we publish to the stream. So it's similar patterns from what we were doing. The difference really comes down to this notion of memory. Like in our previous examples, it was, oh, well, you weren't there subscribed to the message at the time. Too bad for you. That message is gone. But now, because we have a stream, we can have a consumer that comes after the fact and picks up those messages that are on the stream, and then is also able to receive the new incoming messages. So that's why we've got these that are kind of created before the consumer, and then the consumer is started up and set to process those. And then we've got more publishing after those, and it's set up to process the other messages. So that's what's going on there in this code. Then I can run this code, and we'll see how that works. And then, so I think the bottom is mostly like cleanup code. It's a little less interesting, I think. Oh man, there's a bunch of things that I forgot were on here. So we'll run it, see how it goes, and. So we now have our thing streaming. I should be able to do, assuming I remembered to delete the stream last time. It's also not designed to when an existing stream is present. So it gave me errors when I did that. So I might have to clear some stuff, but we'll try. Good, that's what I expected. So it created those first three, then between, it then created the consumer. Then we got the got thing. And then I didn't talk about it, but there are different kinds of consumers in this world. There's something called a durable consumer and an ephemeral consumer. So getting back to like that diagram we had before, you can imagine that, hey, maybe I am like bringing on a new consumer to handle this this stream indefinitely. And from that moment on in time, it's going to be processing any of the data that's coming in from the producer and just doing something with it. But it starts at like point in time at message 6. So you might want to create an ephemeral consumer that same service runs and says, let me process everything that happened before to like kind of play catch up as a backfill for this thing. Now, in something that's short, okay, you can probably just start at 1, but there are scenarios where these different ephemeral and durable consumers can have different roles about how they're used in the streaming lifecycle. So that's that's streaming in a nutshell. I don't know if I described it super well, but it's my attempt on it anyway.
So, do you have examples of situations where, like, because I can understand the concept of like the backfilling in it, but I think I'm losing like what would be a good use case for this kind of streaming, like.
Sure.
I guess maybe like something other than like streaming a TV show, or something like that.
You're reporting your position. You're some unit reporting position.
So here's a pretty good example.
You're updating a map, and you just want to see the latest one.
Yeah, there's.
You'd have to see like you'd want to be able to like play catch up and like rerun all of the state to like rebuild your.
Right. Here's a pretty, I think, fairly simple example that you can maybe latch onto. There's a concept called event sourcing. So in this, we've been viewing these messages as like, okay, maybe I want to do something and react, and I'll persist that state to the database. Okay. But in the world of event sourcing is another idea where I don't have a database. I leave the state on the stream. The source of the data is the stream. So at that point, you can have like that compaction, those checkpoints become really important, because if I ever want to learn what's the current state of the world, kind of like the git ref log, like the git builds its log, and like how a git clone knows what's the current state is it goes back and looks through that whole log, and there's compaction that's all in there. So it kind of models that similar way of like if you treated a stream like that and treat it as a data store, you could have consumers that are like, whoa, okay, what's the latest view of the world?
I guess I'm having trouble with like when would that be a better idea than having a normal database? I think that's kind of where
now we're getting into distributed systems problems. And so the problems that come up when you have there's a dual write problem that can occur when you're dealing with a secondary store like a database, where it's possible that one of those systems could fail, the event system or the database, and so you can be left with an inconsistent state of the world. There are ways around that. There's something called the outbox pattern to make the on transactional boundaries write to both data sources at the same time. So the idea behind event sourcing, at least, is let's eliminate that whole category of these really thorny distributed systems problems that most people aren't even aware of that exist, and let's make it one data source so that problem set just goes away. Now, I don't know that NATS is the best event sourcing tool out there. There's other technology out there that their sole mission in life is to act as a data store that is an event sourcing data store that's like designed. I'm drawing a blank on the most popular one, but its whole purpose in life is to be, I'm going to be your event sourcing data store. So deliberately working in this way where you're keeping checkpoints and having consumers and looking at a log, and that works well for certain kinds of data. So
another use case that's very useful is eventual consistency. So you could have events being generated, like transactional, you're buying things, you're selling things or whatever. You as a consumer might want to get the message right away that yes, your transaction went through, but the Amazon's database might take longer to update. So they can have separate consumers on these streams where one is like updating the database on the transactions that occurred while you're getting immediate knowledge that your order's complete. Or it could be, decrementing what the stock is. Database writes are way more expensive than reads, so it doesn't want to have all these things stacked up all the time and you waiting for something much longer to finish. When they can have you moving on to the next thing and buying something else, as long as that stream is maintained, they can let the other things catch up. So,
So there are a lot of these like subtle cases that, and you as you get more
That's-
into
and that
these
stuff gets
asynchronous
lost.
patterns, like
It's like-
you learn like, wow, distributed systems are super hard.
Like
To
command
get
query
right.
response segregation, so like that's exactly
Yeah,
what that is.
CQRS, yep.
Yeah.
So we've seen jet streaming. Okay, so now that you've got a notion of I have a data store, what can I do with that? The last thing that I'm going to describe here is NATS can do cool other things that you wouldn't even think about. So this one is a key value store.
This is S3 or something.
It also I'm not going to talk specifically about it. There is an object store that can be used. This is the like lightweight version of that where the values are small. But
Yeah, what's the Amazon key value store?
S3.
Dynamo.
Oh, no,
Dynamo,
no.
yeah,
Dynamo,
That's what I was
yeah.
thinking of, yeah.
And I don't know if did y'all hear the latest Redis news? Familiar with
Is
this?
Redis dead or is what's the
Redis, the company that owns Redis, has relicensed it in, I think, not good ways for the open source world. As we're here at Frederick Open Source.
The developers quit and fork it or something, or
Yeah. So my shallow understanding of the history of Redis is that there was a gentleman named Salvatore, I don't know his last name, who was like the guy that was working on Redis for a long time. And at some point, he lost interest. Maybe 2014, I think, is it? I could be wrong. Don't quote me on the dates. So he lost interest, and now there's this super popular project where the guy is like not the guy anymore. And so Redis Labs came in and were acted as the stewards of this software. And I think their rationale, what they would tell you on their website is, hey, we're getting killed by Amazon companies like Amazon being able to offer. It's the same thing as like HashiCorp. HashiCorp did something similar recently. It's like, we can't offer all of our services for free and then let these other commercial competitors just repackage our stuff and sell it as the enterprise version, whatever. So I think that was the logic that this Redis Labs group used when relicensing Redis. And I don't know, I think it probably means that Redis as we know it will be a lot less used in the future. There's one called Redict, which is like a fork of the last Redis version on that license. There's another one, I don't remember what it is. Point is though, NATS can do now it's not a drop-in replacement for Redis. You can't just like point to a Redis or point a NATS URL to some Redis client and it'll be happy. And it's also doesn't have all the bells and whistles of Redis, but in terms of the things that are classically in a key value store of the gets and puts and deletes and like all of those attributes that are there are available to NATS. And I believe it does that by building on top of a stream. So there's a notion of a bucket, which is probably just under the covers. It's probably a NATS stream that's acting as the storage, and you can put keys and values in there. So I have a demo here on that, and it will be the last demo that we've got for the evening. So we're using our connection to JetStream. We're creating a key value bucket called profiles, and then we're doing a bunch of puts and gets and things on there. Like we're showing an example of, I believe these are gets where there is no data yet. Oh, no. There's a put right here. So we've got Sue.color. Again, I did not make this example. So there's like Sue.food, I think, somewhere in here. There's a few things that are sort of blended in here. But it's sort of the stuff you'd expect from a key value store. It's meant to just kind of run it through its paces of being able to do this and show this. What's interesting about this to me when I saw the results, so I'll go ahead and run that.
You can also watch it.
Yeah, you can watch it, and then the thing that I thought was kind of cool, assuming this all runs, yeah. So this is actually this error here. That one was intentional. In the code example, it shows there's a way to set, make it fail if I don't see a specific revision. But what's fascinating to me is that all of these puts are versioned, essentially. So you get like a version history out of the key value store here, which I'm sure you could take advantage of by saying I want revision 4, which was yellow on this. I don't know exactly what scenarios you'd use that in, but it's like, oh, that seems like a cool feature. This is not NAT's primary reason for existence, but they're as part of being, the NATS developers seem to be of a mindset of like, hey, if you use NATS and use these things, you can eliminate a lot of what's in a typical microservice architecture. So if you had NATS at the hub, you could see like, I could get rid of load balancers. I could get rid of message queues. I could get rid of point-to-point communication, like over gRPC. Like there's a whole lot of technologies that become, no, let me just use one tech stack and let that be act as the hub and interact with it in a bunch of ways. And so they're extending that with like a key value store is a very popular thing. And then, as I mentioned a moment ago, they also have the notion of object storage. So that's like an S3 bucket. So all of those are become available through a NATS setup here, where it gives you like a total package for a lot of stuff. Now it's not offering a relational database like that. I don't think that they'd go that far, but I don't know. I didn't expect there to be a key value store and an object store in here either. So surprising.
And so you probably, like you said, like this would be at the hub and would need to be pretty, so like with like the microservice and then the monolith and then like moving in and out, like, so this would then have to be treated as like the first class, like has to be up at all times and
So
have to be very well provisioned, cannot be like on a small.
exactly. Yeah. So
Can
if you let it go, I mean, you could use as much or as little of it as you wanted to. If you just wanted, like, maybe you just want the streaming feature and you just want asynchronous messaging and want to start using it there. So I can see many paths to just gradual or partial adoption of it and still have it be wildly successful in your stack. But yes, if you wanted to do all of these things and totally build your system on NATS, you'd probably want a high availability HA setup. And like I think I said at the beginning, this can run all the way down to Raspberry Pi, although it didn't seem to run that well tonight. And it can run up to like multi-region. There are many NAT servers that are talking and doing coordination with each other through consensus algorithms and figuring out.
When you do the connect in your code, can you connect to a list of addresses, or do you?
Yes, yeah.
Okay,
So
right. So
it's
you can have that.
right, and because of the transparency of how that works, I think it does some routing shenanigans, I'll just call them, so to make that as easy as possible. And they gave examples on the documentation of what that looks like. So you can go up pretty advanced with having a very big setup. And then I think, that was it for the actual tech and of different types of patterns here. The only thing that I had was this of just, there's different stuff that we don't have time to talk about. We saw a little example of this though, although the load balancing, the queue groups concept, when we did multiple responders, that was an example of load balancing made super easy. You didn't have to know, there's no ALB in the equation here. It just worked, right? So that's pretty cool. The other bits about that I think are probably more advanced functionality that you might use if you're going all in with NATS is service discovery is a hard problem of, I don't know, if we're dealing with that aspect of network transparency that they talked about, of like, how do you even discover what's out there and what's available to do these request response API calls against? What subjects can I talk to? I don't know. And so service discovery is like a protocol that they have that allows every service in the NATS mesh, fiber, I don't know what term they use for a connected ecosystem, but every participating service can broadcast and say, like, I am this service, here's my version number, here are the endpoints, the subjects that I support, and provide like metadata around that to allow services to get to talk to each other and know how to communicate with versions. I think that they extend that to they're working on a toolbox called NEX. I don't remember, I'm drawing a blank on what NEXT stands for at the moment, but it's essentially a deployment toolkit of if you wanted to not get pulled into Kubernetes and doing all of that, they're saying, hey, if you're already going to be doing NATS for everything, we can deploy your stuff. We do a little bit of configuration of what your NATS topology would be for your hardware that you'd need to run, and we run essentially a provisioner on top of it that kind of manages those things, and then these NATS services can then integrate with that pretty quickly. That last piece is the most in development from what I see in their documentation, but it looks promising of what it might do. In fact, I mentioned Firecracker the other day on the Discord that they're using Firecracker under the hood to do lightweight micro VMs to really densely pack a NATS cluster, if you will, to make all these services run. So that's NATS. Hopefully y'all learned something, and I appreciate
Cool.
taking the time.
Yeah.